Hello everyone, welcome to my channel. This is Naresh Chenno. In today's session, we'll see the all basic concepts related to the network theory. In this lecture, we'll talk about basic definitions and Ohms law and some controlled sources and KCL, KVL, voltage division rule, current division rule. Finally, we'll see star delta conversions, and after that we'll see the all questions related to the all these basics, and we'll see how to solve in easy manner, and we'll see some shortcuts also. So our first basic quantity of the electrical network is the charge. The definition of the charge is an electrical property of atomic particles of which matter consists. Means if you take any body which contains the atoms, so atom will have one electron, proton and neutron. In that we have charge. So either it will be positive or it will be negative. If it is positive charge, we'll call as the proton. If it is negative charge, we'll call that as the electron. If you see, the units of charge is coulombs, and this charge will represented in Q. So one electron will have 1.602 into 10 power minus 19 coulombs. And if you see the magnitude of this electron, the value, it will be negative because charge of electron will be negative. So next quantity is electrical current. Electrical current is the time rate of change of charge. This is related to the charge, and it is the current measured in amperes. Now I will show you here. See, this is Q is equal to charge and I is equal to current. The relation is current I equal to the time rate of the rate of change of charge, means dq by dt. The rate of change of charge is current, and this is in coulombs and this is in seconds. So coulomb by seconds will get ampere is the unit of current. If you see any electrical network, current is the main fundamental quantity for the electrical circuit. And next one is voltage or potential difference. This is nothing but the energy required to move a unit charge through the element, and it is measured in voltage. What does it mean is, if you have one element like resistor, so here whatever we give, we call as like VAB. This is only the voltage. Voltage is means the energy required to move the particles, means charge per unit charge through the element. The energy required to move a unit charge through element, that is called voltage. This is voltage. This is voltage. If you see the polarity, I have connected positive here, negative here. If you connect negative here, positive here, we will call this as a minus VAB. Means this terminal I will call A and this be AB. The voltage between these two terminals is positive in this case and negative in this case. This is regarding voltage. And if you see the two types of currents in electrical network is, one is direct current, one is alternating current. If you see that one, this one, whatever the one is this DC, two time one is this. So if you see this current, this is DC, means direct current. The value which is constant with respect to time. If you see this value, if it is 5 volts or 5 amps, it is same every time, means the value is constant. And if you see this quantity, this is alternating means one positive value, one negative value, again one positive value, and we'll get one negative value. Means it is changing with respect to time in two manner, one is positive manner and second is negative manner, means it is varying alternately. That's why we'll call this alternating current. Alternating quantity may be the voltage also, that case we call as the alternate voltage. If you see the DC, the example is DC batteries. This is the best example for DC sources. And if you see the AC sources, we have function generator, or we can call as what we are getting in what you call the output of alternator, that is our 230 volts AC supply. This is also example for alternating quantity. So now we'll see power and energy. Even though in electrical network we see mainly voltage and current, but when you see real examples, like if you go to shop and purchase one bulb, we ask 100 watt bulb and 60 watt bulb. Here we will not talk about currents. So that is the main importance of the power, which relates the importance of the electrical circuits. So after that, if you see our electricity bill, it gives based on the consumption of energy. So this power and energy both are related, and in electrical network these two are very important. If you see, the definition of the power is the rate of expending or observing the energy, how much it is consuming the energy, which gives the power. Mathematically, energy denotes this integration of power dt. This is a mathematical formula to calculate energy if you know the power. And if electrical network, we will use this formula mainly, means power equal to voltage times current. So this is the fundamental formula to calculate the power. And if you see here, the power observed and power supplied, what does it mean is that in any electrical network we will talk about two quantities, one is power consumed, one is power supplied. In later I will discuss more on this. Now if you see here, the algebraic sum of power in a circuit at any instant time must be 0. What does it says is the sum of the power in electrical network is always 0. It obeys this one, power observed equal to minus times of power supplied. And the next quantity is energy. Energy is the capacity to do work, and it is measured in joules. So if you see on watt hour equal to 3600 joules. Yeah, now if you see here, while solving the problems in network theory, we will see mainly two quantities, one is observing power, one in supplying power. So what does that mean is, if you take one element here, I will take one resistor here, this is passive element, and if you see the polarity of this voltage across that is positive, negative, and the direction of the current is in this direction. So if you see here, this is plus and same thing is this. So I entering at the positive terminal, the main important is the I entering at the positive terminal. So this is observing the power of V times I. Means if you take one resistor, it has polarity like this, and current I entering here, this voltage drop across resistor R, and if you see how much is power observed or supplied, if you see this power observed by this resistor is V times I. That's what I showed here. If this current is in opposite direction like this, the power supplying is negative times of V times I, because if you see the passive components, they won't generate the power, they only consumes the power. So that's why we got here negative. Most important law is Ohm's law, that states that the voltage across a resistor is directly proportional to the current flowing through the resistor. Yeah. Now we'll take one resistor So I will take current entering like this. So for this for passive resistor, the direction decides the sign of the resistor. So current entering, I current entering at this terminal, so I have mentioned here positive and here negative. So the voltage across this capacitors, resistors are, so as per voltage, I mean Ohm's law, V proportional to I. So I will replace that with times IR. This is what Ohm's law. So if same case, same resistor, current entering at this terminal, so we will take as this is the positive terminal for resistor. Always while writing the V, we should know the I where it is entering at terminal of the resistor. If it is entering at positive terminal, it is entering at this side, you mention this positive. If it is entering at this side, you take that sign is positive. And if you see here, we can write some three relations: V equal to IR and I equal to V by R equal to V by I. From this only I derived this, from this only I derived this. So these three are forms of Ohm's law. In next slides we'll see how we can apply these in networks. And next one is short circuit, second one is open circuit. What does it mean is that the circuit element, the resistance approaching 0 is the short circuit. If you see this is one network. Here resistance is 0, means any network you are like this. You want to make the short circuit of that circuit at that particular node, it will be like this, because these two nodes are joining together. This is short circuit path. Here if you see, as per Ohm's law, we have V equal to IR. So you want to know I in the short circuit path, I equal to V by R. So what we mentioned is R is 0. So V divided by 0, 1 by 0 equal to infinity. So in short circuit, the current is infinite. So that's what here it is, infinite current will go. And if you see open circuit, you open the terminals of the element where you want to see the open circuit. So in that case, if you measure the resistance, here, will get infinite. Again, as per this, I equal to V by R, V times R equal to infinity, 1 by infinity, 0. So in open circuit, the current is 0. These two are important for us. In short circuit, current I equal to infinite. In open circuit, current I equal to 0. These are the two main important things when we solve the problems. Yeah. Next, we have four types of dependent sources, which are, one is voltage controlled voltage source, second one is current controlled current source, voltage controlled current source, as well as current controlled current source. So if you see these four diagrams, we can easily identify. If you see, this is voltage controlled voltage source. Why is this is the triangle symbol for sources, it represents the dependent source. So if it is like this is voltage source. If same triangle, arrow mark means this is I. Why these are independent? Means because these sources values depends upon other variable, that is controlled variable. That's why these sources are dependent sources. If you see here, again this is voltage source and this triangle, so dependent voltage source, and the value is controlled by V1. So this is V1. This is the parameter which controls this source. That's why we call voltage source, this triangle voltage source, and controlled by voltage. That's why voltage controlled. If you see here, this is again triangle, positive negative. This is voltage source, yes, and controlled by current, Yeah, this is I1. So that's why this I1 is here. So the variable control, the variable which controls this source is current. We see here, this is, yes, current source controlled by current parameter. So current controlled current source. Again, if you see, this is current source controlled by voltage. So current source controlled by voltage. These are the 4 different types of dependent sources. Yeah. Next, very important law for network theory is KCL. What does it say is the algebraic sum of currents entering at node is 0, or in other way we can tell the sum of the currents entering node equal to sum of currents leaving the node. So if we have take one node, so one current leaving and entering and entering. So what does it say is at particular node the sum of the entering currents always equal to sum of leaving currents. If you see here, I1 is entering plus entering currents will note down, I3 entering and I4 entering equal to sum of the leaving currents, I5 and I2. This is about KCL. This is nothing but just at one node what are the entering and leaving currents. And second law is Kirchhoff's voltage law, that we will call as a KVL. It states that the algebraic sum of all voltages around closed path, yes, around closed path is 0. It tells the voltages around closed path what is the value. So how we can write the KVL in any closed loop? First we'll see, this is a voltage source which is having terminal negative here, and direction of the current we take like this. So current is like this. So already I mentioned this is the resistor passive element. Wherever the current entering, first we'll take a positive, and again current is coming like this, again current entering at this terminal, so we have taken positive, and same current is continuing. So this is also one element, you can take a resistor and entering at this terminal, so we are taking positive and negative. So one loop we formed. Now we will write the KVL. So I will prefer always to write from negative to positive, means V1, because we are entering from negative to positive, means we are gaining, negative to positive gain. If you have lost some 5 rupees, you are gaining 10 rupees, so we are gaining, so that's why I mentioned here positive. Again here the same is continuing, current here it is positive, means we have already 10 rupees, we are coming down 5 rupees, means loss, so we can write minus V2. Again gain to loss, again negative, again here negative, here positive, so we are gaining, so plus V4. Again here entering at positive and positive to negative, again we are losing, so V5 is equal to 0. This is what KVL. Simply you see the current where it is entering. If it is negative to positive, you write positive quantity. If it is positive to negative, you write negative of that particular symbol. So entering here negative, so I wrote positive, entering at positive, so I wrote negative, like I have continued. This is KVL. If you see here also same thing used, so that's why V1, V2, V3 replaced by this equivalent circuit. So next is series resistors and voltage division. So voltage division principle we can use when two resistors are connected in this fashion. So now we can find the V1 and V2 by using the voltage division rule. So if you see the current I in series network, it is coming like this. This is also I. So if you want V1 and V2. How we can write is, see, V1, the voltage source, full voltage source, multiplied by, here I am writing V1 R1 divided by sum of the resistance values R1 R2. How can we write V2? V2 is voltage across resistor 2. So how we can write the voltage source of full across the resistor divided by R1 plus R2. It's simply one example I will take. I have 10 volts here. How much V1 and how much V2? That we can get from this. I will take, this is 2 ohms, this is 3 ohms resistor. Now we have to find what is the V1. So if you see, the 10 volts times R1 is 2 ohm. The sum of 2 plus 3 is 5. So this is 4 volts, and again 10 times it is R2. R2 is 3 ohms. 5. Here I have 6 volts. If you see V1 plus V2, we got 4 plus 6 equal to 10 volts. This is equal to our source voltage. Sorry, what does it mean is the sum of the drop across resistors R1 R2 are infinite. If it is R3 also, this drop also will consider all these drops equal to the source voltage. This way we can write the V1 and V2. Now same in parallel circuit, we'll see the current division principle. What does it see? See is the, here if you have I total, it will divide in this fashion. How we can write this I1 and I2? The total current is dividing between two networks. So if you see I1 total current times, here I want to write I1 total current multiplied with the opposite resistance. In KVL we wrote same, now we will write opposite one times same. Here is R1 plus R2. How we can write for I2 is, this current we have to write again total current times this is what I mentioned at R1, again opposite one. If you want to find I2, you first write this one. If you want to find I1, you have to write this value. So I times R1 by, this is what writing the current division, means currents in the parallel network. It's quite opposite to the voltage division. So if you see this this I dividing between R1 and R2 to find I1, and means in this path this I1 we can find by this, and I2 in this path we can find current I2 by using these formulas. Means I will take one example here only to make you clear. I am getting from here some 10 amps, and again this is 2 ohms, this is 3 ohms. Now I want to find the I1. So to find I1, the total current 10 into R2 3 ohms divided by 5, this is 6 amps. Now I want to find the I2, this current. So again I times total current times 2 ohm by 5, this is 4 ohm. Again if you see this I1 plus I2 equal to 10 amps. So what does it mean is the current, total current is sum of these two currents. So if we have one more path also, the total current I equal to sum of 1, 2, 3, these three paths. That's what the current division says. So this is all about current division principle. So in next lecture we will see the Y delta transformation and the basic all problems which we saw till now, and we'll see the all tricks and shortcuts. I hope you understand the all concept, and any suggestions or queries, please comment in the video, and please subscribe. Thank you for watching.